All right, so my favorite, exponential relationships. You deposit $2,500 and you're going to find the balance after 3 years with a 2.5% annual interest rate. And it's compounded monthly, round to the nearest dollar. All right, so what that means is the equation for compounded interest when you have an annual rate, but it gets compounded not annually, is going to be your principal times 1 plus the rate divided by how often it's compounded. In this case, that's 12. And that's going to be the number of years in this case, and we're going to multiply it by 12 because there are 12 months. So, here we go. So we have $2,500 times 1 plus the rate is 0.025 divided by 12. And that's taken to the 3 years, 36. All right. So then from here, compounded monthly. All right. So then from here. All right. So I'm going to pull up my calculator. I am, but hold on a second. I can stop it. Time out. Okay, sorry about that. All right, so we have 0.025 divided by 12. All right. So that means we have 2,500 times 1.00208. That's all to the 36 power. All right. So pull up my calculator here. Very exciting calculator. All right. So, can you see this? Yeah, kind of. All right. So I'm going to do 1.00283. And I'm going to take it to the 36 power. Hit enter. And so there's my actual annual interest rate. So I guess I misspoke, but you get the idea. And so now I'm going to multiply that by 2,500. Hit enter. So I end up with roughly, what is it? $2,695. All right, we'll do the other one too. All right, so the sloth population is increasing exponentially. 1 second. All right, so we're back. Sloth population is increasing exponentially by 25% per year. How long will it take to have a population of 8,000 sloths? I actually got to see a sloth climbing a vine once. It took a long time, and then he got tired and just stopped and slept. Okay, so exponential relationships, we're talking, and especially in growth, we're talking about y is equal to a times b to the power of x, where a is the y-intercept, b is the growth factor. So, what that means is my y-intercept, or initial population, is I didn't write that down. So the initial population is 200. So we have y is equal to 200 times my growth factor is 1.25. Now that is growing really, really fast, folks. And that's to the power of x, because we don't know how many years. So instead of writing x, I'm going to put y for years. All right, and so in this case, I want to know when the population gets to 8,000. So instead of y, I'm going to write 8,000. All right, so first thing I'm going to do is divide both sides by 200. So cross out the zeros, and 80 divided by 20 is 40. So 40 is equal to 1.25 to the power of y. Now to get the y by itself, y is going to be equal to the log base 10 of 40 divided by the log of base 10 of 1.25. So when I do this on the calculator, and as much fun as it is to look at me type into my iPhone calculator, I'm going to skip that part from this one, and I get an answer of approximately y is roughly equal to 16.5 years. So really, actually, pretty quick and simple problem. You know what? I'm gonna just do the last one as well in this video. All right. So the last one, we're simplifying. This one's pretty straightforward. 2, I have a base of 2, which means I really need a base of 2 here as well. And 4, luckily, is just 2 squared. And I'm taking that to the x minus 1 power, and that's all over 2 to the power of x squared. Well, let's simplify the exponents here. And we'll get 2 to the 2x minus 2 power over 2 to the 2x power. Now this is when we go back to our rules of exponents, and we know that we're going to subtract the exponents because we're dividing by the same base. And so that's going to get me 2 to the 2x minus 2 minus 2x. Well, 2x minus 2x is 0, that cancels out. So we get 2 to the negative 2, which is equal to 1 over 2 squared, which is equal to 1/4. And that's it. All right, so that's the entire review packet. I hope this was helpful, and good luck.